In this quick lesson regarding logarithmic functions, we're going to cover transforming a log function to an exponential function and vice versa. Our base log function, y equals log base b to the x, can be rewritten as x equals b raised to the y. Our base b, you can see, stays the same. Whatever is next to the b then switches over to the other side of the equals, and the last remaining number becomes the new exponent. You'll see what I mean in a second. X equals b to the y can be rewritten y equals b to the x, and you can then go in the other direction. The base b stays the same. Whatever was next to the b switches over to the other side, and this y now becomes the new argument, as they say. So, to go through a couple practice questions, if we wanted to state the inverse of this log function, but in y equals format, we would first switch it to an exponential function. So our base here is 3, which stays the same. Y becomes its new exponent, and x, which is the argument, switches to the other side. Since they want it in y format, we can then switch this to y equals 3 to the x, because these can simply be swapped. Same thing, if we want to switch y equals 7 raised to the x to the inverse, first we should switch the x and the y. So first thing, x equals 7 raised to the y. Now we can switch this into a log function. Our base, 7, will stay the same. And since x was on the other side of the equation, it becomes its new argument equals y, which is all that's left. So now we can go through and change all these log functions into exponential functions. Starting here, log base 7 to the x equals 4. 7, our base, stays the same. X was already beside the 7, so we know it can't be the exponent, so it has to be 4, and all that's left is now x. Here we have log base 5 to the 15 equals y. Our same rule still applies. That was bad. So our base 5 is the same, but we now raise it to the y, and 15 switches over to the other side. Here we have m equals log base t to the b. T stays the same because it's our base. M comes to the other side, and all we have left is b. Last one, 5 equals 4 log b to the 6. So first we need to get rid of this 4, and to do that, since 4 is being multiplied by log b to the 6, we simply divide by 4. Whatever you do on this side, you have to do on this side. So we have 5 over 4 equals log b to the 6. Now our same rules apply. Our base b stays the same, and the 5 over 4 switches with the 6. And that is switching from logarithmic to exponential functions. Now we're going to do a few examples doing the opposite. Switching over from exponential to log form. Same rules apply here. So, you have 4 raised to the 3, or 4 cubed, equals 64. So, we can change this to log. Our base, 4, stays the same. 64 and 3 can now switch because these switch sides on the equals. So log base 4 to the 64 is 3. Part B, 2 raised to the negative 3 is 1/8. So, same thing. And they kind of give you a clue here because remember, in your log form, your x, or your argument, can never be negative. So, your base is the same. you can't put negative 3 here, so it almost has to be 1/8 equals negative 3. Part C, e raised to the d equals f. It's very simple here. So we write log. Our base e stays the same. F and d switch. And finally, 2x plus 4 equals a raised to the 5. This seems tricky, but the same exact rules apply here. So we'll write log. Our base here is a. And even though it has 2x plus 4 here, the whole thing can go inside. So 2x plus 4 equals, all we have left now, 5. And that is switching from exponential to logarithmic function.